Hello class. We're going to do a quick tutorial on confidence intervals for proportions. Alright, so we've done some for averages, and we're going to talk a little bit about proportions. Alright, so there will be two general equations. They're not different, but for 95%, and we also want to look at one for 99%. Okay, so a 95% confidence interval, we take our p-value plus or minus 1.96 times standard error of the proportion, and if we want to increase that our confidence, of course our margin of error is going to increase, and that's 2.58. And these numbers should be very familiar to you because they're a z-value. I'm just writing them out like this so you don't actually have to go back to the z-value. These are the most common confidence intervals used for proportions for two-tail, right? We have a plus and a minus here, all right? So for 95%, the z-value is going to be 1.96. For 99%, 2.58, all right? So we know these right here. P is the sample proportion. SP is sample standard error of the proportion, which is calculated right there. Quite simple. Okay, so an example, and this is based upon an actual ballot question in Maine. This is not based upon any data that I actually saw. I just made this up for an example here. So a local poll in Maine contacted 400 registered voters and asked if they were voting yes or no on ballot question 1. 52% said yes, they were in favor of ballot question 1 and were going to vote yes on that. So what is the margin of error for this? Now, what we want to do is, 3 steps, all right? We already know what P is. P is 0.52 right there, based upon the percentage that were in favor. So what we need to do is find the standard error of proportion, and we find the margin of error by multiplying the standard error of proportion by our z-value, and this for 95% confidence interval. And then we just add and subtract to create our window where our true population proportion resides on this question here, okay? So how do we calculate the standard error of proportion, all right? So we know P is 0.52, so we're going to place that in there. And we know that N, our sample size, the number of voters who were queried on this, is right there, all right? And what that calculates out to is S of P, which is our standard error of proportion, is 0.025. And if you recall, and just make sure you remember this, is that as N increases or decreases, our standard error right here is going to increase or decrease, okay? All right, so we're looking at what our margin of error is. So our margin of error here is 0.049, so it's about 5%, all right? So now we determine our confidence interval right here. So our true population proportion for this right here is between 47% and 57% of folks are going to would vote in favor of this. Now, if you were on either side of this issue, you wouldn't be very happy. Okay? Because if yes is right in here, you know that there's still a slight chance that you're going to lose this one, and the accuracy of this information is based upon your sample size here. Okay, so for this to decrease, if you recall, this is 0.025, so this by itself is 2.5%. To have a better confidence interval, okay, you would need to increase your sample size from 400, okay? And that is the example for confidence intervals for proportions.